So now that we know what the general graph of a logarithmic function looks like, we can take that idea and connect it to ideas we talked about earlier in the semester, the idea of transformations. So as you look at example 5, part A, they're asking us to graph the function y equals negative log of x plus 5. Now as I look at this problem, I first of all notice that I have a negative 1 being multiplied on the outside. If I'm multiplying by a negative 1 on the outside, I know that that's going to be a vertical reflection. A vertical reflection is a reflection across the x-axis. So I can take my base function, y equals log base 3 of x, and I can reflect it about the x-axis. So once again, I like to start with my asymptote. So if I take x equals 0 and I reflect it about the x-axis, it's still going to be the vertical asymptote x equals 0. So x equals 0, there it is, and we'll draw that dashed line. 1, 0, a point on the x-axis is going to stay on the x-axis, so 1, 0 is still 1, 0. 3, 1, I'm going to reflect that across the x-axis. Another way of saying that is I'm going to multiply the y-coordinate by negative 1. So 3, positive 1, when I multiply that y-coordinate by a negative 1, it becomes 3, negative 1. So down here we have 3, negative 1. And then the same kind of thing, 1/3, negative 1. In order to reflect it about the x-axis, I need to multiply that y-coordinate by negative 1. So it's going to become 1/3, positive 1. So there it is at 1/3, positive 1. So now that I have those, I can go ahead and draw my graph. An interesting thing to note then is that when I flipped this graph about the x-axis, I ended up getting a graph that was decreasing everywhere that it was defined. So now that I have that first change in mind, let's think about what's going to happen in terms of that addition of 5. Notice where that addition of 5 is. The addition of 5 is on the inside of that set of parentheses. That means that's a horizontal transformation. In particular, it's a horizontal shift. Remember that horizontal shifts are backwards from what you would expect. So when you add 5, you're actually going to go to the left 5 units. So now let's take this second graph and shift everything to the left 5 units. Once again, I'm going to start with my asymptote. So x equals 0, if I take that entire vertical line and move it to the left, it's now going to be over at x equals negative 5. And then the point 1/3, 1, if I subtract 5 from that, I'm going to get 4 2/3, 1. So let's plot that. 4 2/3, 1. The point 1, 0, subtract 5 from that x-coordinate, we're going to be over at negative 4, 0. And then finally 3, negative 1, subtract 5 from that x-coordinate, we're going to be at negative 2, negative 1. So negative 2, negative 1. And then when we connect those dots, we have our new and improved function. So the graph of y equals negative log of x plus 5, and I should have a base 3 there. The graph of y equals negative log base 3 of x plus 5 looks like this. We have a vertical asymptote at x equals negative 5, and we go through the 3 points negative 4 2/3, 1, negative 4, 0, and negative 2, negative 1. So now that we have this idea of what our graph looks like, we can also write down the domain, range, and the vertical asymptote for this function f. So the domain of f, well, the domain is the set of all x values that we use, and again, you never cross through a vertical asymptote, so we can't pass that x value of negative 5, but everything to the right of it we can use. So our domain of f is going to be parenthesis, negative 5, infinity, parenthesis. The range of f is all the y values that we used. We're actually using everything. We're going up forever and we're going down forever. So the range is all real numbers. In interval notation then, that's going to be parenthesis negative infinity, positive infinity, parenthesis. And then finally our vertical asymptote is x equals negative 5.